Hello and welcome to this pre-recorded event for AS and Advanced GCE Mathematics. Feedback on the paper for Mechanics Module 2 sat in June 2015. To help you get the most out of this feedback, you may want to have the following documents handy, as they will be relevant to the content of this session: the question paper, the mark scheme, and the report from the principal examiner. In the course of this session, delegates will receive feedback on national performance of candidates in Unit M2 of the June 2015 examination series, consider the variation of candidates' performance on different questions and possible reasons for this, look at the examiner's report, address common issues and FAQs. Candidate results on this paper were very similar to those in the equivalent paper last summer. These statistics show an increase of 1 mark in the mean score and a small decrease in the standard deviation of the scores. There was no change in the score needed for an A grade, but an increase in the score needed for an E grade. The next few slides in this presentation consider the outcomes question by question. Some screens include examples of candidates' work. You might find it helpful to pause the recording at these points to allow yourself longer to consider what the candidate has done. Starting with question 1. This worked well as a straightforward first question. Candidates demonstrated a good understanding of the relationship between power, driving force, and speed. 75% of all candidates scored full marks. There were 2 common sources of error in question 1. The question does say that the van is moving down the road, but either through haste or possibly through not understanding the situation, more candidates than usual worked with the component of the weight acting in the wrong direction in the equation of motion. Several candidates confuse themselves by using the same name for the driving force and for the resultant force. They tend to use F for any unknown force rather than giving different forces different names. Turning to question 2, the lamina in this question was quite simple when compared with some shapes that candidates have dealt with in recent past papers. The first part of this question was very straightforward. The question describes the lamina as a square with a triangle removed, and this is how many candidates treated it. Other popular options involved splitting the shape into 3 triangles, ODC, OCB, and OAB, or drawing a horizontal line through O and using a rectangle and 2 triangles. This candidate has split the shape into a pair of trapeziums. They calculate the area correctly, but unfortunately they do not know how to locate the position of the centre of mass of the trapezium. Their method is to average the coordinates of the vertices, and they stop when they realise that they are not getting anything that looks like the given answer. In part B of this question, the key to success was clarity and organisation. This candidate starts with a clear, fresh diagram and starts by finding the position of the centre of mass relative to point C. They have not given a long description of what they are doing, but everything is clearly set out and easy to follow. In summary, most candidates scored some marks in question 2. The modal score was 4 marks, often scored through a correct answer to part A. 29% of all candidates scored full marks. In part A, the work was generally good, but there were algebraic and arithmetic errors. Many candidates did not attempt Part B. Those candidates who attempted to answer Part B often assumed that the centre of mass of the combined system was at O, rather than on the line AC. In question 3, 54% of all candidates scored full marks. Part A of the question tests the impulse-momentum equation in vector form. Most candidates demonstrated a good understanding of this and applied it correctly. Many candidates reached a correct expression for the velocity of p after the impulse, but they did not then have a correct method for finding the angle between the two velocities. Because the initial velocity was 4I, the task was quite straightforward, but perhaps it seemed to be difficult to those who were not confident working with vectors. A small number of candidates went wrong because they confused the impulse with the initial velocity, so they were not actually finding the required angle. In Part B of Question 3, there were many fully correct solutions. The question asks for the change in kinetic energy as a result of the impulse. Some candidates found this more difficult, either because they applied an incorrect formula for kinetic energy or they used the correct formula incorrectly. The most common error was to use mv, or mv over 2, in place of mv squared over 2. Weaker candidates were often not confident in working with vectors in this context. Some used the magnitude of v minus u, and some invented methods for squaring a vector. Question 4 proved to be a challenge for many candidates, although over 40% of them did score full marks. The context should have been very familiar, but the lack of structure left many candidates unsure of where to start. The responses ranged from clear, concise answers, such as this one. To confused responses, such as this one, where the candidate has not broken down the contact forces at A and B into normal reaction and friction. The only mark scored here was the method mark for using the correct value for the trig ratio. To summarize, the most common sources of error for candidates in answering this question. Most candidates attempted to form a moments equation, but these often had terms missing or dimensionally incorrect terms. There were also some trigonometric errors in the resolving. Use of incorrect trigonometric ratios. Some candidates found the angle and then used decimal approximations to the trig ratios. Others were confused by the use of 5 and 3 and assumed that 4 must be involved somehow as well. Use of WG in place of W, because they had not noticed that they had been given the weight rather than the mass. Arithmetic and algebraic slips in the course of the work. Poor naming of forces, leading to confusion and/or more unknown values than necessary. Question 5. On work and energy was a good source of marks for many candidates. Almost 45% of all candidates scored full marks. Many candidates demonstrated a clear understanding of the concept of work done against friction. Almost all candidates followed the instruction to use the work-energy principle to answer Part B. When a particular method is specified in the question, any other approach will score no marks, even if it does give the correct final answer. When things did go wrong. In Part A, some candidates included the change in potential energy in their calculation of work done. The substitution of 9.8 in place of G results in an answer of 5/12 on many calculators, but an exact answer is not acceptable following the use of a decimal approximation for G. In the work-energy equation in Part B, there were terms missing, usually either the work done against friction or the change in gravitational potential energy. Some candidates double-counted by including both the change in gravitational potential energy and the work done against weight, although this error was not as common as in some recent past papers. Question 6 was a good source of marks for most candidates. 94% of all candidates obtained the modal score of 8 marks or better. Almost all candidates scored full marks for parts A and B. The common error was to find the displacement of P from O at the end of the interval, rather than the distance travelled. This candidate has integrated correctly, subtracted the displacement at t=5 from the displacement at t=0, and given the very common incorrect answer of 55/6, having taken no account of the hint provided by the answer of Part A of the question, which should draw their attention to the two values of t at which there is a change in the direction of motion of P. This candidate has split the motion into 3 parts correctly and reaches the correct conclusion. They include a sketch of the graph of displacement against time, but do not appear to have used it. For many candidates, question 7 was the most challenging question on the paper. The modal score for this question was full marks, but fewer than 30% of all candidates achieved this. 10% of candidates scored 3 marks or fewer. Many struggled with Part A, often not getting as far as a pair of simultaneous equations in mu and theta. Those candidates who used Suvat equations to write down equations linking the horizontal and vertical components of the velocity at O and at A were usually successful, but candidates who used distance formulae made little progress. Part A can be solved by considering the energy of the particle at O and at A, but few candidates adopted this method. Parts B and C can be answered independently of Part A, but only the stronger candidates noticed this. Instead of starting from A and working with the values 15 and 20 given in the question, many candidates preferred to work from O and use their calculated values of mu and theta. In this question, many candidates lost accuracy marks through giving overspecified answers following the use of 9.8 as an approximation to the value of G. Final answers in Part A were often given to more than 3 significant figures, and 127.5 was a very common answer in Part C. This level of accuracy cannot be justified when working with 9.8. In Part B, many candidates found a correct value for the time taken to move from O to B, but made no attempt to find the time taken to move from A to B. Many candidates made a confident start to question 8, demonstrating a good understanding of conservation of linear momentum and of the impact law. Almost all candidates started with a correct pair of simultaneous equations and used these to find an expression for the speed of q after the impact. This is always a popular topic with the candidates, and this time 30% of all candidates scored full marks for the question. The end of Part A proved to be a good test of understanding. Several recent questions have involved consideration of the direction of motion. This approach is not correct in this instance, but was nonetheless very common. Only a minority of candidates realized that Q needed to catch up with R for the second collision to occur. Answers to Part B often lacked clarity in the presentation, explanation of the conclusion. The question tells the candidates that there will not be a collision, and a given answer requires accurate evidence to be provided before the mark can be scored. Candidates who start off with a clear diagram indicating direction of travel and using simple names for the speeds of the particles at each stage tend to have an advantage in this type of question. The lack of a clear diagram often led to confusion over what needed to be found and the directions of motion of the particles. At the end of Part A, many candidates compared their value for the speed of q with 0 rather than with 3u, possibly thinking about the direction of motion and not that it needed to catch up with r. Sign errors in the impact equation in Part B were quite common, especially for those candidates working without a diagram. Some candidates did not use the given value of E to find the speeds of P and Q after the first collision, so they did not have sufficient information to be able to complete Part B. Can you work out what this candidate has done? You might like to pause the recording for a while to look at the solution. In Part A, they have the right idea, but they have a sign error in their impact equation. Minus 6u should be 6u. Despite this error, they do find an expression for VQ, and they do make the correct comparison with 3u. In Part B, although they find the speeds of P and Q, there is nothing to indicate, in words or on a diagram, the direction of motion of P. The denominator of the impact equation in Part B should be 0.25u, not 0.25. They cannot score the final mark because they do not have correct speeds, but the final conclusion should be about directions of motion, not the relative speeds of the particles. Marks M1A1, M1A0, M1M1A0, B0, M1A0, M1A0A0, giving a total of 7 marks. There are some things that all candidates can do to improve their performance. Take care over the accuracy of final answers. The rubric on the paper is very clear about the value that candidates are expected to substitute for G when a decimal answer is required, and the appropriate accuracy for the final answer in these cases. An accuracy mark will be lost in each solution where an answer is overspecified. Clearly labelled diagrams really do make a difference. They help the candidate to clarify the information given, and they help the examiner to follow the candidate's thinking. Give a brief explanation of what they are doing at each stage. This makes it much simpler for an examiner to follow their work. Make sure that your answer matches what the question asked you to find. If you would like to know more about examination statistics, you may find the links on this page of interest to you. GCSE and GCE Reform. What's changing and when? GCSE English subjects and maths are changing first for first teaching in September 2015, with first assessments in summer 2017. GCEs for a range of subjects are changing first for teaching in September 2015, with first assessments in summer 2017. We have just published our specifications on the Edexcel website. They have been published early in draft form to enable teachers to have early sight of our proposed approach. We are also running a series of launch events too. Our draft specs and SAMs, as well as further information about our launch events, can be found on edexcel.com. Other GCSE and GCE subjects following in 2016 and 2017. Thank you for using this feedback presentation. We hope that you found it useful. We constantly look for ways to improve the delivery of our training and appreciate all delegate feedback. You will soon receive an email directing you to our online feedback form. The form takes no more than a couple of minutes to complete. Please take the time to let us know your thoughts by filling in this short form.